Curvilinear motion, motion of projectile. Motion of projectile refers to free thrown motion of object that given initial velocity at a certain angle. Once in the air, we can assume that the object is only subject to the gravitational force just like as free fall motion. Therefore, only experiences a downward gravitational acceleration. Since there is no other acceleration, the motion can only happen within 2D plane defined by initial velocity and therefore drive the general strategy when dealing motion of projectile. Here, the object is given by initial velocity v0 and the path of motion of projectile is shown. Let's put this path in the 2D rectangular system, x and y axis. From convenience, the x always choose as a parallel to the horizon and the origin can be arbitrary. The object has an initial position x0 and y0. An initial velocity can be resolved into components, v0x and v0y. At the given time during this motion t, the object has reached a new position with new components x and y, and it has a new velocity component vx and vy. And we wish to drive the formula that enable us to find objects in new position and new velocity. Don't forget, as I mentioned, only a constant acceleration g in the negative y direction and no acceleration in horizontal direction. Also, horizontal motion and the vertical motion take place during the same time. From previous slide, we understood the acceleration of projectile in x direction is 0. And in y direction equal minus g. Also, if we consider the initial position of projectile in x and y direction is 0, is meaning the O as the origin, and so the position x and y is 0. By first integration, we find the velocity in x and y direction. By twice integration, from acceleration, we find the equation of object in x and y direction. Note that the motion in horizontal direction is uniform. Also in vertical direction is uniformly accelerated. See, for ax is 0 and acceleration in y direction is minus g. And finally, the motion of projectile could be replaced by two independent rectilinear motion. Let's look at one example. The path of projectile is shown. If the object has initial velocity v0 equal 30 meters per second that is perpendicular to the slope, determine the d. The slope of the d with the ground is 30 degrees. Okay. We select the origin as the initial position of object and we resolve the initial velocity to Vx and Vy components. Okay, now we write the equation of motion for x direction. X equal x0 plus V0 xt. Okay, the V0x is 15 meter per second. For y direction, y equal y0 plus v0 t minus half gt2. And for v0, y equal 26 meter per second. Okay, we substitute in the equation. Now we have to find the d. When the, okay, for x, we have to resolve again d to x and y direction. For the, in x direction, d, we have d cosine 30 degree, and for the y is minus d sine 30 degree, because the origin here, okay, and the y is downward. So when we substitute to these two equations, we find the t equals 7.06 seconds and the d equal 122 meters. Thank you for your watching.